Okay, good. So, hello everyone, and welcome to another episode of the Sustainability Webinar Series. Today we have Daniela Pigosso, who will present her work on how to design for absolute sustainability in a world of rebound effects. This is the Sustainability Working Group from INCOSI, and yeah, without further ado, I would just look forward to Daniela to present yourself and your work to us.
Yeah, thank you very much for the opportunity of being here today to share a little bit about my work. I'm an environmental engineer by background and always had this intention of minimizing environmental impacts before they happened. And during my education, I actually got very frustrated because the focus was mostly on treating pollution after it was there. So, how to design a wastewater treatment facility or an air emissions cleaning facility. And I really wanted to be more and more proactive. And then one day, walking around the university, I saw this big sign of a conference that was happening on life cycle engineering. I had no clue what that was about, and I decided to join, and that completely changed my career from there onwards. There, I learned that most of the impacts that the humankind has in the world has to do with the production and consumption of products, and that the early stages of design are actually defining most of the environmental impacts across the entire life cycle of products. And then I started to work a lot on eco design.
We lost the sound.
Yeah, I think we lost you, Daniela. Ah, okay, Daniela is back.
Do you hear me now?
Yeah, now we hear you.
Okay, cool. So yeah, I was focusing on eco design and trying to understand how to minimize the impacts across the life cycle of products, then expanding that to product service systems, to social technical systems, and circular economy when it came. But what really struck me is that after having worked with many companies in all sorts of different sectors, that it didn't really matter how good our intentions were when those products were put into the real world, people would change their behavior in ways that would offset their overall potential gains. And that's what led me to work on rebound effects and on understanding how we can actually prevent them by design. And I would say that, if you look overall in the world, there are actually already many different solutions that are targeting sustainability across a wide range of different societal needs, over mobility to consumables, nutrition, and also housing. And I really think that we have come a long, long way when it comes to achieving a more sustainable way of living. If we look around us, there are so many sustainability innovations out there, and they span a wide range of different areas, all the way from business to business innovations, but also business to consumer innovations. If I were to focus on three ones as examples, we could, for instance, talk about energy efficiency in housing. So never before have we been so efficient in consuming energy to keep our houses either cool or warm through insulations, better windows, even through more efficient lighting systems and so forth than we are today. And I think it's really reaching state of the art in terms of energy consumption. If you look into mobility, we know that single car mobility is probably not the solution moving forward. And then we've seen also innovations across business models, trying to understand how we can design effective car sharing systems that would allow more people to have access to the same cars. And by doing that, requiring less cars to fulfill the same mobility needs of a given population. And then if you go one step forward, sustainability innovations are not only about products or systems, but they're also about policies. And here in Europe, we see a very strong increase in policies that are targeting at enhancing the overall sustainability performance across life cycles, such as the new Eco-Design Directive, that is, for instance, incentivizing sufficiency, so less consumption through the reuse of textiles. And I could keep going for the entire time we have together today, sharing a wide range of other different sustainability innovations that are really taking us a step forward and allowing an increased population to fulfill their needs at the same time as keeping their environmental impacts low. If you look at Europe alone, there's also a huge investment coming from the European Commission for Sustainability Innovations. So if we put together the European Green Deal investment plan, plus what the European Investment Bank is planning to put on sustainability up until 2030, it goes up to 1.75 trillion euro. So, I really have a reason to be optimistic in relation to how far we've got in terms of sustainability. But the question that really I think is important to ask here is it enough? We've never seen so many sustainability innovations as we do today, but are they enough to help us to be within the safe operating space? And well, the answer is a big no. And I think it's no surprise to you that we are really living a sustainability crisis. It's not only a climate crisis, because if we look into the planetary boundaries today, actually 7 out of the 9 planetary boundaries are transgressed. This means that despite all of the efforts we've been having the past 30 years in putting forward sustainability innovations, and again, I think we've been successful in doing that, we are still consuming more than the Earth is capable to deliver to us. Here you see that for many of the planetary boundaries, we are already in an area of high risk. For some of them, we are in an area of increasing risk, and only 2 of them are within the safe operating space: the stratospheric ozone depletion and also atmospheric aerosol loading. Now, why is that happening? Why all of the potential benefits that we could be getting from those sustainability innovations are not being shown at a systemic level? And well, if I bring the very same examples back to you again, I really want to show you the other side of the story and what is actually happening when we introduce those innovations in the real world that leads to a less than anticipated environmental benefits. If you go back to the energy efficiency, what happens in many cases is that this also leads to lower costs for fulfilling the energy needs that you have. And as a consequence, people tend to reinvest the savings into enhanced energy consumption, especially when money is a constraint in consumption in that given region or country. And in some other cases, because the actual energy efficient products become cheaper, let's take LED lights, for instance, people end up using and buying more lights than they would otherwise. And instead of turning them off when they are not in a room, they are actually on for almost 24/7. So if you look at the systems level, what is happening is that despite the energy efficient solutions and technologies that we are having, people are consuming more, and as a result, we are consuming more energy than we would otherwise be doing. If you look into the car sharing example, I do think it's a brilliant idea and a really nice initiative for allowing more people to have access to the same car. But what actually happens is that people start driving in a different way, and they don't take the same care as they would in a car sharing systems in comparison to a traditional car ownership model. A few years ago, I was participating in a big conference in China, and there was a key executive for one of the big car sharing companies in Europe sharing the success case of that given car sharing in terms of minimizing the environmental impacts. It was an electric vehicle, and they were saying all of the great things about it. After the keynote, I went to ask him about the lifetime of the car when it is put into a car sharing system. And he told me that in a traditional ownership model, the lifetime is about 10 years or 200,000 kilometers. But in that, the car sharing, it was different. Does anybody have a guess of what is the lifetime of a car when put in a car sharing system?
5 or 7 years, or less than that.
Yeah, so that's less than 10 years, that's right, but it's less than 5 years. Any other guesses?
Well, 3.
No.
Yeah.
Maybe 2, but maybe they sell in the occasion used cars market later. But yes, it must be
Yeah.
very short.
Okay, so it's less than 2 years.
Whoa.
Any
Wow.
other guesses?
1 year?
Okay, you're getting close, but it's less than 1 year. Yeah,
I don't
it's
want
actually
it.
6 months. And when he
Wow.
told me, I was like, no, sorry, I think you didn't understand my question. Let me ask you again. And he said, no, it's really 6 months. After that, and I also thought the car would be resold as a second-hand car, but he said, well, the car is such in a condition that we actually recycle the different parts and components. And I was like, but how can we make that business feasible even from an economic perspective? And he was saying, it's not really, but we've installed sensors all over the car, and we are really collecting how behavior changes. And then we want to design a car that is robust to a car sharing system. That car never came to the market, and the company actually went bankrupt. And it was about 60,000 kilometers over these 6 months. So yes, the cars were being used more often, but if you were to fulfill the needs of the same population, you would actually need 2.5 times more cars to go from the 60,000 kilometers to the 200,000 kilometers. And that's a really big problem. So people take care differently when they don't have ownership. But the other problem with car sharing services is that in most of the cases, they are not really substituting car owning, but they are substituting public transportation or cycling in countries like Denmark, for instance. And in many cases, it actually allows people that wouldn't otherwise have access to cars to drive more often. So again, at a systemic level, we end up actually needing more cars instead of less cars to fulfill the same mobility needs. And then if you go to the final example, and this is a sufficiency example through policymaking, that is really trying to establish the mark of secondhand clothes so that we can actually use clothes for longer and go against the fast fashion industry that is really strong today. But what we see in many cases with secondhand is that it doesn't really substitute buying new clothes, but this happens in addition to new clothes. And more than that, now people feel justified to maybe buy a brand new cloth and just use it a couple of times and then give it for secondhand because they feel that they are actually doing good for the environment for doing so. So in the end of the day, the impact is actually offset again due to behavioral change. And you know, I could keep going describing those different examples and showing how many times the good intentions don't turn into actual benefits. But we wanted to go in our research from this very anecdotal example by example to really having a systematic overview of all literature over the past 200 years since the Jevons paradox came about. And what we found out was more than 500 studies that were looking across rebound effects, but also 190 of those that had tried to quantify how big or how small the rebound magnitude was. We mapped them in relation to different types of rebound effects from direct and indirect to economy-wide. We looked into what were the sustainability interventions that were triggering those rebound effects, and the large majority of the studies are on efficiency interventions, but we also see that effectiveness and sufficiency interventions lead to rebound effects in the very same way. We also tried to see what were the societal needs mostly studied, and we do have loads of studies in both mobility and housing, especially in relation to energy consumption, but we also see a spread of studies on consumables and nutrition cases as well. We tried to understand what was the knowledge area where those studies were coming from, large majority, especially in the beginning, from resource and energy economics, and becoming more and more diverse as time goes. And we also looked into how are they estimating the magnitude of rebound effects. And you see a wide range of different methods in there. But we really want to have a feeling of what is the overall magnitude. And there was a really big variation. It went from a very small 2% rebound effect, which I would argue it's acceptable, and probably we don't need to really worry about that. But it went all the way to 7,000%, meaning that the new sustainability intervention was actually 700 times worse than the ones they were trying to replace. And then in those cases, well, I think that we really need to do something about it. But then, we've done both the average and the magnitude of those measures to have the median and the average of the magnitude. And we came up to a median of 47% of potential sustainability benefits being offset by rebound effects, and an average of about 100%. But I wouldn't trust that much on the average because the range, as I mentioned to you before, was very, very high. So what came out of this study is actually this finding that really stunned us, that about 47% of all potential sustainability gains are never, ever achieved, and this is due to rebound effects. But how do we define rebound effects? So rebound effects for us are all of those negative consequences that are driven by either behavioral or systemic changes that in the end of the day will undermine the overall potential environmental gains. And this definition also expands the overall understanding of rebound effects in many different ways. So traditionally, rebound effects are mostly considered in terms of efficiency measures, but we have evidence that rebound effects also occurs in terms of effectiveness and sufficiency measures. If you look into the main originators of rebound effects, the initial articles all the way back from the Jevons paradox are really focused on energy improvements. But well, we also know that it's not only energy improvements, but a broad environmental aspects that lead to potential rebound effects. Traditionally, rebound has been explored from a mainstream economics perspective that consider mostly economic mechanisms for explaining why and how a rebound effect occurs. And we also expand that to a systemic and behavioral effects that account not only for individual behavior, but also societal behavior. And then finally, most of the studies take rebound effects as a relative measure in relation to a potential intervention that they are substituting. And we take that as an absolute measure, as an intrinsic characteristic of any given intervention. But the bottom line is really that if rebound effects are offsetting 47% of the potential sustainability benefits, this means that if we take only the investment that Europe is putting on sustainability innovations, that we are actually losing about 700 billion euros that we don't manage to convert into actual sustainability gains. And well, I think that this is a big problem, and this is really something that we need to address. to ensure not only that we stay within the safe operating space in an absolute sustainability setting, but also that competitiveness can be achieved by the different companies that are putting those sustainability innovations forward. And then the question really becomes, well, now if we understand that rebound effects occur, we understand that they are triggered by a wide range of different interventions, and we also understand that they are offsetting a large amount of potential environmental gains. How can we design them out? How can we achieve absolute sustainability by preventing the occurrence of rebound effects? And that's exactly what we are doing in the Reboundless project that is funded by the European Research Council. The project started 3 years ago, and we have 2 more years to go. We have 12 people involved in the project across a wide range of different areas. And our main goal is to devise a paradigm shift that would allow us to prevent rebound effects by design. In the very early design stages, when you are still defining what is the product service system, the social technical system, or the policy that you want to put forward, understand how big or how small the rebound effects are going to be in that given stance, and then devise prevention strategies that will allow you to, in the end of the day, achieve the potential environmental benefits with that given intervention. And in the project, we focus on 4 main societal needs: housing, mobility, nutrition, and consumables, that together account for 3/4 of the total carbon footprint. And also because given action or innovation within one of those areas, let's say mobility, might have rebound effects happening not only within mobility, but also within other needs such as housing. So understanding how those different societal needs interrelate in a broader systemic level is also extremely important. And what we do in the project is really to envision what is the future sustainability innovation that we are actually designing. What is then the process that we need to go through for designing that given intervention? And this usually starts by understanding what are the problems that we want to address today. But because we are still not really good at addressing rebound effects in the early design stages, what ends up is that after we've actually gone through this entire process and implemented our sustainability innovation in the world, that we actually make the problem bigger than it was in the beginning. And then we start all over the process again, and this becomes a really vicious cycle. So in Reboundless, we are putting forward a new approach for design that starts by, from the very early design stages, trying to understand what are the potential rebound mechanisms that are being triggered by that given intervention that I want to implement in the real world. And those mechanisms, they can have different shapes and flavors, starting with the most traditional mechanisms that are connected to the traditional mainstream economics, mostly connected to money and what happens when people save money, time, or convenience from one given need and then reinvest that into more consumption. And we have 25 plus mechanisms that explains rebound effects from a traditional mainstream economics. But then we've also expanded that to the behavioral economics mechanisms by trying to understand how each one of us are psychologically influenced by those interventions and how they actually change our behavior in some irrational ways, but at the same time, extremely predictable ways. And here, from a behavioral economics perspective, one example could be moral licensing, for instance, where we think that we are doing something good for the environment, and then we feel that we deserve doing something less good afterwards. So let's say I'm driving an electric car the whole year, and then I feel justified to go to Thailand on vacation by flying over summer because I've actually deserved it. And we found more than 30 mechanisms here. And then finally, we also look at a more societal level, looking into social practice theory and trying to understand how the combination of meaning, competencies, and material changes can also lead to rebound effects at a higher societal level. And here we found more than 30 different mechanisms. So here only you can see more than 80 different explanations for why rebound effects occur. And what we do in the overall process is to say, if I have one given intervention, which of those rebound mechanisms are potentially being activated by those, by looking into triggers, and what is the likelihood of each one of them happening for a given context and a given intervention. And this then takes us to the second step. From the identification, we go to the simulation and the modeling of the overall system so that we can actually understand how the mechanisms work, not in isolation, but in combination in a complex system. And for doing that, we have a bottom-up approach for modeling where we take each one of those mechanisms as building blocks for devising the simulation models that would be applicable to that given innovation. And here we use system dynamics for it. So we start by mapping the causal loops of the different mechanisms and how they relate to the overall system. We then go from this qualitative model to quantitative models that allows us to understand not only what is the overall magnitude of those different rebound effects happening, but also to identify where are the key leverage points in the system. What we are doing just now as well is to have an additional project that is building upon the rebound magnitude and translating that into life cycle assessment studies so that we can not only know the rebound magnitude in percentage, but we can also see what effects it will have across a wide range of different impact categories. And what can happen when we do those analyses as well is that instead of having rebound effects that are offsetting potential gains, we could also have what we call secondary benefits that are helping to achieve more than anticipated gains in terms of environmental negative impacts. Cool. And in this project, we have a wide range of different organizations involved that are really helping us to understand how do we transfer the learnings from the system dynamics models into life cycle assessments to enable a broad uptake of rebound consideration, so that actually the estimations that we have of the potential environmental impacts of our products are reliable and robust. But what this model and simulation also helps us to do, in addition to measuring the magnitude, is to identify where are the key leverage points in the system. So areas where potentially a small change can lead to a high gain in terms of preventing the rebound effects from happening. And that also allows the identification of specific design strategies that enables the prevention of those rebound effects by design. So it always starts by understanding what loops in the system will have the biggest influence into the overall behavior, and to then test a wide range of different design strategies that are coming from a very comprehensive database of design strategies that can be used at either the product level, the product service system level, or the social technical system level across the 12 leverage points areas from Daniela Meadows' work. And this allows us to go from the very generic strategies with a potential for preventing rebound effect to actually understanding for that given specific system that we are simulating to what extent they can help, but also what is the right mix of different design strategies that when put together can help us to achieve a significant decrease in the overall rebound magnitude. And with that, what we actually do is from the very early design stages, understand what could be the potential rebound mechanisms that are being activated by my intervention, how do they fit with each other in a broader system by looking into modeling and simulation. What is the magnitude, but also how we can act to prevent those rebound effects from happening. And the overall goal is, of course, to, by doing that, make sure that we are not only solving the problem that we had to start with, but actually fulfilling needs at the same time as being within the safe operating space. And when we started this project, our main goal has really been on design. So working with industry across a wide range of different areas and helping them to understand and foresee potential rebound effects so that their overall solutions would achieve their potential benefits. But when I really started the project, I really thought that this was still a blue sky type of research. I felt that it would still take a few years for industry to actually realize the benefits of working with rebound effects, but I was actually wrong. Already in the first year of the project, I was contacted by one of the key cosmetic manufacturers in the world, Beiersdorf. They are the company behind Nivea or Labello. And they really saw the importance and the benefits of addressing rebound effects. So we established a collaboration that led us to have a few people working full-time together with them to support with the identification, quantification, and prevention of rebound effects. And we just extended the project for another 1.5 years now. But another area that I wasn't really expecting was a very high interest also from policymaking. So already from the very beginning of the project, we started working with the Joint Research Center from the European Commission to help them to understand how to design sustainability policies that are actually resilient to rebound effects as well. And this led us to a few very interesting outputs with the main goal of understanding how do we identify, quantify, and prevent rebound effects during policy development, especially within the impact assessment areas. So we started with the European Commission and the Joint Research Center. We also involved and have a very strong collaboration with the European Environment Agency. We've also engaged different organizations such as Greenpeace operating at a global level. We also have a wide range of Danish stakeholders from the Confederation of Danish Industry to think tanks, eco-labor organizations, parties, and also ministries. And we are also working with the government of the Netherlands that is focused on circular economy as well. And with those engagements, we've actually not only identified how to develop tools that are relevant for them, but we've also been actively working on developing policy briefs. So this is one that we published in January last year, and we are also working on a follow-up just now, connecting policy instruments with rebound mechanisms. But the overall message here is really that rebound effects happen across a wide range of different interventions and that it is actually possible to prevent them by design. And I think that this is already having a quite big impact in the EU, at least. So there are some additional works being done by the Commission that are addressing rebound effects and recognizing the importance of being aware of them, both when designing, but also when implementing new policies. So overall, I think that it's extremely important for society in general to not only recognize that rebound effects exist, and we've been doing that for quite many years already, but actually to be able to understand how can we, when innovating and designing new policies, new systems, new products, to actually account for rebound effects by helping us to ask the question, are we really solving the problem that we are set to solve, or are we maybe just making it worse? And I truly believe that one way of answering that and achieving the overall potential benefits that we could achieve is through the reboundless design. We've published already a wide range of different papers in the field, all the way from the rebound mechanisms to the model and simulation tools, but also the prevention. And I would invite you all to have a look into that and to, let me know whether you want to collaborate. So thanks a lot for your time. That was all that I had for today, and I'm looking forward to your questions. I don't hear you, Hamza. I'm not sure if you are speaking.
Yeah, but we are uploading.
Yeah, thanks for letting me know. Yeah, thank you very much for the presentation. It was a very great one, and there are already like lots of questions in the comments. So yeah, I guess we can open the Q&A, and yeah, who has a question?
Well, I would have a question.
Yeah, go on, Axel.
Our company is using as an example a car sharing system for a long time already. And I just found out that car sharing systems are offering sensor systems that can detect everything that's happening to the car. And maybe that is one strategy to solve this problem, because then you can find out whether people are treating the car good or not. Is that something that would be a strategy to achieve that?
Yeah, it could be. And I guess that only the sensor in itself probably is not enough. You would then probably need to set incentives connected to the data that is being sensed. So for instance, you can get bonus if you show that you are driving properly and so forth. But installing those different incentives in the system is one way of tackling. I would say with a shallower leverage point, but it's still extremely effective depending on the context that it is taking place.
Thank you, Axel. Yeah, I think when you mentioned like the car sharing businesses, what I found, I mean, it makes sense that they don't last for a long time because those cars were not designed for that usage. I mean, that's like the big problem that they have there. And I'm not sure about reusability and so on also. That's like more of a downcycling than,
Yeah, exactly. And because they were not designed to be put in a shared system, then it becomes very expensive to replace parts and components when they break.
Yeah.
Some of them you might not even be able to change because they were designed to be disassembled and reassembled and so on and so forth. So I think that this is one really important aspect, and it is really about understanding how can we make, in this case, the cars more robust to careless behavior as well. I mean, we might try a wide range of different strategies to make drivers drive more carefully. But if the car is also designed to be more robust, then you can extend the lifetime. And ideally, it would be wonderful if the cars could last 20 years instead of 10, because then the car sharing providers, they would be able to get the benefits from having the cars running for longer, but also we would need less cars to fulfill the needs of the same population. So I guess it's a combination of different strategies there.
Yeah, I think like also like the problem is that mostly like the OEMs are not the one who are running the business. So that's against their business model actually. But I don't know.
Yeah, in that case specifically, they were the same company. It was the OEM running the business as well.
Okay, well, Alain has a question.
Yeah, maybe first on this topic, because I worked a long time for Renault. Maybe the difficulty for those big volume OEM is to prepare a dedicated model for a small volume, at least at the starting point. So they need to be confident in the time there will be a big volume, so they can prepare a dedicated car. But this was not my question. But yeah, so thank you very much. I like it a lot, and in particular you are very optimistic in terms of saying, yeah, we can manage the rebound effect or anticipate. And I have two questions about this. You said you are using models and simulation, and Obviously, the phenomena are complex because it's very often human in the loop or even social. And so obviously the models are rough estimates or anticipations. And so this is for me a first risk in terms of quality of the anticipation, but it's better than nothing. And the question is, do you imagine some ways of having not only prediction, anticipation of the future behavior of the product or the policy, but also designing some control and a closed loop during the use of the product or the policy to be able to change something or to stop to sell the car, even if the car is very well. Okay. Did you also propose some methodology to prepare this closed loop?
Mm-hmm. Yeah, two really good questions. So the first one, how can we trust the results coming from the models, right? I think that there's a lot of calibration that comes into it in terms of collecting primary data for the context in which your intervention is going to be implemented and doing all sorts of sensitivity analysis to ensure that we are not really way off. At the same time, it's really about doing a wide range of different scenarios and trying to understand under which situations will rebound effects potentially occur and how to anticipate them in a way that you can have an action that can be triggered in case they really happen. And I think that this goes back to your second question. Absolutely. So a few of the design strategies are connected to automated sensors that triggers one specific strategy depending on the utilization. So a very simple example could be dynamic pricing. So if you have a system that will charge you more, the more you consume it, when it goes above the overall threshold of needs fulfillment, then that could be a way of avoiding overconsumption. But there are a wide range of other examples connected to that as well.
Okay, thank you.
Thank you very much, Ala. Ali has a question.
Yes, thank you very much for the great presentation. Actually, I see that there is a good linkage between this topic and also by transdisciplinary thinking. So what I can see here is that in some way rebound effects are in some way as a result of bounded rationality and bounded irrationality actually in the design. And what is required actually to address this this bounded effects also is to thinking beyond system from the conceptual phase, from the time that you are translating the stakeholders' needs to the defining the requirements. And here I was wondering that how then the approach that you are taking here to predicting and also then preventing these effects can help in designing new systems in the beginning. So how you will take that one to the design phase?
Mm-hmm. Yeah, I think that the biggest paradigm shift in terms of design is that we also try to understand not only how the intervention can solve a problem that exists today, but how this same intervention will change the system in which it is being introduced, leading to, in our case, the focus is on undesirable effects, but it could also be other positive effects that are being triggered by those and not really taken into account. So the overall goal is really to expand these system boundaries, to have a deeper understanding of how the innovation influences the systems around it so that you can design the intervention in the best possible way. I don't know whether it is possible to reach a zero rebound effects. I think it would be great, but it might be a little bit too optimistic to think so. But if we can bring it down to maybe 5 to 10%, then I think it's already a huge improvement in relation to what is happening today. And it might actually also increase the overall creativity within design so that we can find new and more innovative ways of fulfilling needs than we do today, at the same time as keeping the overall environmental impacts as low as we possibly can. So I really think it's a design problem. and it should be treated as such.
Yeah, then how do you see that these uncertainties can impact these decisions? Because bringing these kind of bounded effects, their sources to the design, then needs some defining some thresholds, some boundaries, and there are lots of uncertainties to defining them. Then is there any possibility to provide any clear, actually, boundaries, any clear thresholds for them to take them to the design phase, or that one also could be a big challenge?
Yeah, it is indeed. And I think that we try to address that from two different ways. One of them, if we see that a given data that we are using, for instance, to calibrate the model is highly uncertain, and at the same time has a very strong influence on the overall rebound behavior that we can observe, then this is most likely the areas we are going to recommend the company or the collaborating partner to collect primary data and have less uncertainty in relation to those, so that we can trust better the models. And this is more from a rebound magnitude estimation. But then the other side would be how much can actually those prevention strategies actually help, because there might also be uncertainty there. And then I think that design is actually very well versed in having those experiments, those quick user feedback and iteration cycles, where we can actually get a quite good understanding of the extent to which a given prevention strategy will work in real life or not, and then use the data from that to calibrate the overall model and understand what influences this will have. So I really think that the uncertainty in design will always be there. That's kind of, especially in the early stages, that's an intrinsic characteristic of the process itself. But what we do here is to provide additional evidence that can support decision making in a way that will hopefully lead to a better outcome.
Perfect, thank you.
Thank you, Ali, for the question. The next one is Lou.
Yes, in system engineering, we have the concept of emerging properties. So it seems like rebound, your thing is really an emerging property of the macro system. But when you're going through and talking about adding the capability, it's really people, process, and product. And it seems like behavior is mostly the people and process piece. So when you're talking about design, it seems like it wasn't really clear what you're talking about design of, because just design of the product isn't going to address the issue as much as the larger thing that includes people, process, and product. So are you talking about design of policies, processes? What exactly you talk about design of? What is the system that you're designing?
Mm-hmm. Yeah, we take three main levels of analysis. So it goes all the way from product design, and of course there will be limitations in relation to how far you can prevent rebound effects only looking at the product. But we also look at product service systems. So overall combinations of products, services, infrastructure, and actor network. And then we also look more broadly into the design of social technical systems. This is from a traditional industry perspective, but then we are also having the policy perspective where we look into the design of policies. Mostly sustainability-oriented policies across a wide range of different application areas, but policies that could be tackling, for instance, products, product service systems, or even overall social technical systems. And what we see is that the higher up we go into this ladder, so towards social technical systems, the more strategies exist to address and prevent potential rebound effects. And yeah, so I think this is one of recurrent pattern that we can see from the research that we've done so far.
So from the car sharing thing, it seems like one of the biggest things is if all the car sharing switches to autonomous driving vehicles, so now the drivers really can't abuse the vehicle because they're not doing the driving. That would be one thing. But if you have cars that you want to make more robust, they would probably have more, the structure and everything would increase the weight of the car, and now the car uses more fuel. So you've kind of went negative from a sustainability standpoint.
Yeah, and I think that it is really spot on. So the case of the autonomous vehicles, this can actually be a really good strategy for preventing one type of rebound effect, that is the careless behavior when we talk about sharing systems. But it doesn't solve the other ones, for instance, that are connected to more driving or to substituting other more sustainable means, such as cycling or taking the public transportation, right? So I think it's really a combination of different strategies, and you are absolutely right. There will be trade-offs. Sometimes, in order to be able to prevent the rebound effects, you might need to have a higher induced impact in the product or the unit of the product. But if you look again at the systemic level, then it should be better. I mean, you shouldn't have a car that is so robust that will live for 50 years, but it's consuming so much energy for running from A to B that it's counterbalancing all of the potential benefits that it could have otherwise, right? Then it becomes a trade-off and an optimization on how do we minimize the overall induced impacts by that given intervention at the same time as we minimize the overall potential rebound effects. And then it becomes an interesting problem to solve by design.
Thank you very much. Yeah, I think, I mean, I think regarding like the car sharing, I don't know of a car that has been designed or developed exactly for a car sharing system. But I mean, at the same time, we can see we have aircrafts that live like for over 30 years and they get used like an aircraft doesn't stop at all. Like if it stands like for a second, not working, it's losing money. And they live for over 30 years. So I think like if someone takes the time to develop such a car, I think it will be realizable. The thing is that it hasn't been done. Okay, then I hand over to Mike, who has also a question.
Okay. Thank you. So a couple of points in terms of car sharing. It'd be interesting to get the statistics from rental car agencies. Usually they have the cars there for a year. But one of the things that I've been thinking is if you have a car sharing, say in a city like Munich or Hanover or Amsterdam, you will have the drivers who drive very little doing the car share, most likely. So you probably have actually more inexperienced drivers as well. So it's a different type of population.
Yeah.
So I leave it at that on that point. But I was looking at the electrification of transportation for the metropolitan area of Toronto. And if I want to sell this idea, I want to look at all the impacts. And it was rather interesting to see the impact of not having the trucks driving through the city that refuel the gas stations. That you could remove most of the gas stations or change them into electric car stations, electric vehicle charging stations. But you would not have the environmental impact of leaking fuel from those gas stations.
Mm-hmm.
Etc., etc. The list is huge. It goes all the way to, there was a paper out maybe, I don't know, sometime in the last 10 years, where a group modeled the health impacts of electrification of transportation in that area. And it was essentially saying that the next car that would be transformed from a gas or like a gasoline type vehicle to electric would save after 50 at the 50% mark would save the healthcare system about $9,000. So you have a rebound effect, but that's only part of the system effect. We need to look at the entire picture from, like for electrification, it's erosion of buildings, noise pollution reduction, healthcare impacts, environmental, like the leaking impacts, etc., etc. On the other hand, you'll have probably a bit more tire rub-off from the electric vehicles, right? So it has to be all of that, not just the human behavior part.
Definitely.
And that makes this a very, very, very complex picture.
Yeah. I
Thanks.
completely agree with you on that. And I would say that while we are today really capable of doing those assessments by using life cycle assessment, for instance, where you can understand what are the induced impacts and avoided impacts of a given intervention, we are less capable of doing that from a rebound effect perspective. That's why I focus on this part. But it's really important that you look at it at a systemic level, because it could well be that the new intervention with the rebound effect is already still better than the one that they're trying to replace. And in that case, we should definitely go in that direction. But if we can, on top of that, also prevent the rebound effects, then the benefits will be even bigger. There was a couple of slides that I've hidden from the presentation. I'll just show it again. Because I think it connects really well to what you've just mentioned. It's actually also connected to electrification as an example. So let's say that we have a baseline scenario where we have the traditional car ownership for combustion engines. And if you look across the overall life cycle, across different impact categories, and you put them all together, we could come up with a given figure of what is the normalized impacts across the product life cycle. If we are to add a flavor of absolute sustainability into that, we can also see what is the safe operating space that can be allocated to mobility in terms of combustion engines, and that will kind of give the overall target that you need to achieve. Let's imagine now that we are evaluating a new intervention, so a new sustainability innovation that would be not only electric vehicles, so we would significantly minimize the impact during the use phase if we have a more renewable source of energy. And that will avoid a wide range of different impacts in doing that, that we would when compared to the baseline scenario. Now, what also happens when we have electric vehicles, as you know, is that we need to have batteries, and batteries are not really good in terms of the chemicals that go into them and the resource-intensive processes. So this will lead to additional induced impacts that are connected to toxicity, related impact connect to the batteries, and so on and so forth. So here, this is the usually measure that you get when you do a traditional life cycle assessment. You take the exact same function unit, let's say 200,000 kilometers over 10 years for a family of 4 in Toronto. And then you compare and see what are the differences there. But what this doesn't account for, and this is where the rebound effects would take place, is actually on what are the additional impacts that are triggered by either behavioral or systemic changes that will lead to an enhanced overall negative impact. And by doing that, offsetting the overall potential gains that we could have. In this case, even with rebound effects, I think we should definitely go for it, because overall, this is leading to gains in terms of the overall impact. But it could also be that some other cases, the rebound will be way bigger than what it is substituting. Then, well, in those cases, we either really manage to prevent the rebound effects from happening, or we do not really go to that solution because it's just making the problem worse. So this is to say that, yes, rebound effects need to come on top of the traditional analysis that we do in terms of environmental impacts of interventions. And they are basically addressing changes of behavior that are triggered by the intervention itself. I hope it makes sense.
Okay, thank you. Kai, you had your hand up. It's not anymore. Is your question gone?
Well, I mean, it was very much a follow-up or link to what Mike has been asking. And I think just to reinforce, and thank you so much, Daniela, for this excellent presentation, number one, the work you do, and especially also pointing to the complexity we're looking at, because I think one of the points I wanted to make is that how it sort of pushes us really to a different granularity and into the social realm without just looking at consumer behavior, because it's the enabling circumstances surrounding this. So I think the knowledge we need to gain here and the combination is vital, and we just have tons to learn there. And maybe just allow to the little comment on the policy, which would be lovely if Daniela can comment on that further. My impression is that we're only gaining now sufficient visibility and understanding of the effects so that this can be articulated and hopefully pushed forward, as Alain commented in the comment section there. So more for me, what I wanted to underline again is that I liked hearing how you said that it's a social access. So we would have a positive benefit for people who usually are out of the access to car sphere. So how do we negotiate this sphere is more common, but what your research points to as well. And I think it's important to not forget that, because we have a tendency to focus too much on the technology and the product with respect to that. So summing up, no real question, apologies. I'm just happy that we're reaching those spaces, is what I'm trying to say.
Thank you,
Yeah,
Kai. Anna?
Yes, I have another question. I wrote it in the chat, but it's better if I try to explain it. I think sometimes companies will be happy to do that, so to look for rebound effects, or maybe politicians will be happy to look for overall problem and saving the planet. But sometimes companies or politicians will not do that. And I wonder in those two cases, did the Reboundless project think about some regulation to add for the products, for the companies, or maybe some law or some constitution, I don't know, to make it sort of mandatory before delivering a product, to show a file or explaining how we anticipated the risk of rebounds, and the same for politicians. It should be, I think it exists because there is sort of impact analysis in any politician decision, but at least to enrich this, to look for rebound effects.
yeah.
Well, is it part of the project? Maybe Reboundless didn't
do
this.
If you look into policies, you are spot on. The place to consider rebound effects would be into the impact assessments, and they happen before each and every policy is implemented. And we've actually looked into European impact assessments the past 20 years to try to see how many of them actually accounted for rebound effects. And the number is 27 out of 47,000 impact assessments. So it's very low, but it's already being taken care of. I guess that the biggest challenge for them is that up until today, there wasn't really a systematic methodology on how to account for rebound effects. And that could be a very extensive process that you might not have the time for when you were doing those impact assessments. So one of the key focus areas that we have in the project, I was actually at the European Commission back in November to advocate for that, for the importance of addressing rebound effects in impact assessments. We are now developing a toolbox to make this process manageable by policy advisors and policymakers that we are planning to launch in October. And then we are building a big splash event to really make it available and out there for policymakers. And actually last week, I just got contacted by one specific government wanting to have support for evaluating rebound effects of 6 different initiatives that they're putting forward. So I think the interest is there, and now the methodology is getting there as well, which is really in the right direction. In terms of industry, what we see is that companies that have set science-based targets, they are more interested in addressing rebound effects. I'm not sure if Anna's mentioned to you last time, but the science-based targets is one of the most promising initiatives that are driving carbon reduction in terms of absolute sustainability in industry. If you look into adoption, it's really going exponential, and companies are more and more voluntary committing to extremely ambitious carbon reduction targets in alignment with the Paris Agreement. What happens there is that they have a fixed budget of carbon emissions that they can have, that it's not really based on how many products they are selling or not. So if they grow and they're selling more products, they still need to keep the carbon emissions at the level that they've agreed with in terms of a budget. And what companies are seeing is that if they are to reach those science-based targets, they need to be more ambitious in relation to what types of design changes they are implementing. Only changing material or only changing the thickness of the packaging will not really be enough. They need to be more transformative. In many cases, changing their overall business model. But the more transformative and the more radical you are, the higher the potential for triggering rebound effects as well. And if the rebound effects are happening, they will not be able to be within their budget for carbon emissions. So we really see that as a voluntary way for why companies are interested into rebound effects. I'm not sure whether there will be policies that will mandate all companies to do a rebound effect analysis. But what we are trying to do is really to make it easy to do it by integrating into life cycle assessments. So there are already many countries where you can just communicate about environmental impacts if you've done a proper life cycle assessment. So if we manage to bring rebound effects in there, and say every time you do a life cycle assessment, you must also consider rebound effects, then it's probably a way of moving industry more broadly into that direction as well.
Okay. But you said for some companies, the products, they have commitment on one product, whatever the volume. But for instance, in the automotive area, there is a CAFE, Corporate Average Fuel Economy, which gives a real estimation of how many CO2 was emitted only by cars, not all along all the life cycle, but for all the cars sold. So not only the single product, but the amount in the year.
This one, so they define 3 types of scope. Scope 1, that is connected to emissions by the company inside the factories. Then they have scope 2, that is connected to emissions in terms of energy that they buy to fuel the factories. And then there's scope 3 that takes both upstream, so all raw materials that they buy, all suppliers that they have, and so forth, and also downstream, taking the products in use and also end of life. And those science-based targets.
Yeah, I think we lost Daniela.
He will come back.
One question I would still like to put to Daniela is, I used to be in startup ecosystems, and I really would like to see this somehow transmitted there, because there is so much of it which is never tackled with the last hype idea there. So,
well, that's a good question. I think the thing is that what I also want to ask is, I mean, you just like adding more and more complexity to the topic. And if you are a startup and just starting and you see that you have to do so much work before you even get into designing your product, you're like, what?
yeah, but I think we've made it too easy. I've seen, and even especially because the systemic lens is absolutely not present in the startup ecosystems, and it's only a couple of them starting now. So there's so much, again, incentives, etc., and energy pulled into things which should already not leave the starting gates, right? So there's...
Daniela is back.
Okay, excellent.
I'm so sorry. I'm not sure what's happening with my computer, so I'm in the phone
No problem.
We're happy to have you back.
Yeah, I'm sorry. I
So
don't
we
know
lost you
what's going on.
mid-sentence there. Can you maybe, Alain, you're still in
Yeah, of
reply now?
course. So
Yeah.
I was saying that there are 3 scopes. So scopes 1, 2, and 3. While scope 1 is more connected to the manufacturing itself, scope 2 is the energy sources, and then scope 3 accounts for both upstream in the value chain, so all of the materials or services that the companies buy to produce their products, but also downstream in terms of the use phase and the end of life of those products. And the budget that they get covers those 3 different scopes, and it's independently of growth. So if they start selling more, it basically means that they need to minimize the unit per, or the impact per unit, so that they are within the overall budget. And rebound effects really don't help there, because if they are needing to have more impact to fulfill the same needs with the same kind of overall revenue, it's not really a good idea. So we see most companies that are targeting at rebounds, they are those that have set science-based targets so far, but it could be a way of integrating that into life cycle assessment studies and so forth.
Thanks.
Thank you very much. I have a question. Yeah, so very interesting work, but I just noticed that the more we dive into sustainability, the more we notice that there are more and more things to consider. And this adds just like a lot of complexity. And at the same time, I just can't stop wondering if there is not a simpler solution. Maybe like also like a question like on the work that you have done on rebound effects. So also a point that Lou mentioned. So the question is not really more on the products, because the product is deterministic and we know what happens after that. It's more about how the people use it and society, which is more indeterministic. And rebound effect kind of is like the unwanted behavior that has negative impact on the environment. Did you consider also having like regeneration, which will be like a reinforcing loop with positive impact on the environment? How would that like calibrate in that sense?
Yeah, definitely. And I think that regeneration actually takes the whole equation to a very different perspective, right? Because if you have a given intervention, innovation, that is actually regenerating ecosystems instead of depleting the overall resources or polluting the overall environment as a net positive value, then actually it becomes quite interesting that people consume more of it. And then actually, maybe if you have really net positive solutions, it would be wonderful to have rebound effects happening because they would lead to even more consumption of those innovations that would be having a net positive impact in society. I think that so far it's very anecdotal what you find in terms of regeneration. And I haven't really seen a good example that is truly net positive. So I think that there are good examples where they are minimizing the overall negative impacts by regenerating specific parts of the ecosystem, but it's still net negative. But I really think that if we manage to go towards that direction, then the beauty would be that we use the same mechanisms that has led us to growth and to fulfilling needs that we have today through consumption to actually restore and regenerate the ecosystems around us. So I think it would be a really interesting kind of area of research to investigate further.
Yeah, thank you very much. Just like a short comment before I jump to the other ones that also have a hand. Yeah, so the Cradle to Cradle NGO assume that there are like many who have things like this, especially in the building sector, where I think it's kind of achievable because you have more space to have trees and all these things. But in consumer products or other things, I think for me it's difficult. But yeah, good to know. I think that's a very good point to know. Okay, I think Ali, who had the hand first, Ali or Saneli?
Yes, just I have a quick question regarding these rebound effects, because I wanted to know that usually these rebound effects will come and will be assessed correctly when the product will go out and then people can use that product. Then we will do some assessment. We will see that. So now what is the effect of these new products? I want to know that how these rebound effects can help us to develop new future products or new future systems to have less impact on the environment. So we already have, and we are already doing impact assessment using LCA actually for sustainability. And this rebound effect assessment is kind of new things that will be added here. But in some way, it's a bit uncertain. It has lots of ambiguity that because before going and sending the product out, in some way is not easy in some aspects to determine what would be the rebound effect.
Mm-hmm. Yeah, that's a really good point. And this is, of course, another important data source when we are calibrating the model. So if you do already have a former version of your product or system in the market, and you are capable of measuring the rebound effects, but also why they are happening, then all of this information can be fed into the simulation models for the new design that you are putting forward. This will significantly minimize uncertainty and help decision-making towards a given design feature that will potentially prevent the rebound effects from happening. The thing is that this data today is usually not collected. And if you look into how rebound effects are estimated today, it's mostly at a macroeconomic level, which holds loads of assumptions behind them, because then it becomes very difficult to understand why they're happening, but also how to prevent them from happening. So I think that for redesign projects, building upon data from existing solutions is definitely a way to move forward.
Yeah, but in some cases, for example, like that example that you mentioned regarding car sharing. So before implementing this solution out and doing lots of experiments is not easy to understand and evaluate the rebound effects. So I mean, is there any way that we can add new criteria to the conceptual design, to the beginning of the system development, and in some way the final product be more sustainable?
Yeah, I think that something that is really interesting is that we've managed to map what are design features that usually trigger rebound effects across a wide range of different product categories. And this allows us, even in the very early design stages, to have a good understanding of what could be activated or not, and then also how the design can be changed on the basis of that. Imagine that as some heuristics that come after a wide range of different analyses that allows you to, with a relatively high level of certainty, to foresee them happening. Because as I mentioned before, what is super interesting about behavior is that it is in many times irrational, but at the same time extremely predictable. And I think that this is what we take into account in integrating that into the early design stages.
Okay,
Thank you. Saneli.
First of all, thank you very much. Great to see this type of thinking is happening and that this amount of time is going into it, so I appreciate that. Question is, who is currently the front runners in using this thinking? So you've mentioned policymakers, but do we actually have companies, commercial companies actually using this already and actually starting to get some benefits out of it?
Yeah, I think that the long-lasting company collaboration that we have is Beiersdorf. They are the third biggest brand when it comes to cosmetic manufacture. They are the company behind Nivea and Labello. And we've been working together for the past 1.5 years in actually bringing that forward into their design process. We had an event back in December where they shared their view on why they are considering rebound effects and what they got out of this collaboration. It is available online. I can share the link with you so that you can hear from them. The other companies, we are also working with companies within the built environment area. And we are also working with companies into the mobility industry. I cannot share their names yet due to confidentiality agreements. But I think that it's new for them. They see the potential and they are really trying to understand how this can add on to achieving science-based targets, as I mentioned before, but also ensuring that their products remain competitive in the market. So that's what we are trying to do together.
Great, thanks. It would be great to see that link as well.
Of course.
Thanks.
Good. Yeah, thank you very much. I think we're slowly getting to the end. Yeah, Daniela, I mentioned that I would like to present you like what we do in the working group. You still have time for that, or?
Yes, I'm
Yeah?
super curious.
Okay. Okay, I will do it very briefly. So I will share my screen. Okay, can you see my screen? Yeah?
Yes.
Okay. Yeah, we will look at why is this important? I think we already know that. Mission, purpose, outcomes of the working group, our activities, and how we work. It may be on systems engineering first, like probably you have heard of it. I don't know how involved are you in the topic, but it's a transdisciplinary and integrative approach. So we definitely acknowledge the diverse disciplinarities, and we try to bring them together to develop or engineer systems. Yeah, that's kind of what systems engineering is, and throughout the life cycle. Yeah, so sustainability, why is it important? Yeah, there was an ECOSY SE vision for 2035, and sustainability is the first mega trend there that's going to influence systems engineers. And yeah, in this context, so the working group was created in the middle of February in 2025 with the mission of establishing sustainability as the core of systems engineering. And yeah, taking into account that we have a finite planet and we want to engineer systems so that we can live, try to live like forever in this planet and not extinguish in a short time. So we had like organized a panel at the IEEE conference. We had our formal public working group announcement, then also at the IW. Then there is a book of knowledge for systems engineering, the C book, where we contributed with the first chapter on sustainability, and now we are bringing more bigger chapter on what sustainability is and how to implement it and so on. And then we have here some ECOSY products. So our activities, there's this Sustainable Together project which is like a practical project or kind of a case study. We are taking as an example a PV system or a company that sells PV systems, photovoltaic systems, and we want to show how to transform conventional business model and enterprise and products into sustainable ones. So we show how, like the develop methodologies, and demonstrate them like using digital models. So we are using model-based systems engineering, which is like kind of digitalization of systems engineering. So we work with digital models, develop solutions, and make them open source. And yeah, there's a GitHub repository where we have all these things. And within that, we have the Cascara involvement. So there is a OMG standardization for Cascara. They are developing a standardized knowledge graph for the whole complete life cycle. And we want to use this technology to develop a digital product path, for example. And the same technology can be used for other analysis also. So for example, rebound effects and all these things. So to gather the data throughout the life cycle. Then we have the monthly webinar series that we use also to learn about topics that we don't know about or where we have less knowledge, and we also use it as networking with other communities and so on. Yeah, here we have the Incosi products. Here's some outreach stuff. Then we are starting a project where we want to compare sustainability standards and frameworks to see how they are interconnected or not. And also there's another project on techno-solutionism risk that probably and certainly technology is not the solution for the problems that we have. So we can already be sustainable with the technology that we have today. Yeah, so within this sustainable together, so we really go like to address sustainability, you need to do it holistically. And we say if you are a company and want to become sustainable, you need to start at the mission and the vision of the company. Then you will definitely need to look at the business model, how you create value and capture value. When you change that, you probably need to also to change your enterprise architecture, and then of course the product design and all the enabling systems. Yeah, and then here we have also like design for sustainable behavior. So this is where, for example, rebound effects will come in. And then we have the life cycle stages and the use stage. And then we have the circular economy strategies. And ideally, we want to eliminate waste. And yeah, here we have the technological cycle. And then here we have the biological cycle and regeneration and so on. And then we have holistic topics like systems thinking, system dynamics, rebound effects, digital engineering, all these kind of assessments, the all LETs, and then risk analysis. So we are trying to consider the big picture. And yeah, here we have also standards and regulations. And we are doing that like kind of practically with an example. Yeah, so yeah, and this is our
Maybe a
current
quick question.
Yeah.
How are you considering rebound effects there?
We just started, so we still didn't really consider to that point. So we had already like the presentation, like the first episode where we had the rebound effect, and now yours. So we got a starting point where we need to look at. So we will have a deep dive in your work definitely in the future.
Cool.
Yeah. And yeah, probably what's going to be also what could be like interesting for you is that we will be using like model-based systems engineering, like system modeling and so on, and try to bring these rebound effects into it. So this could be like topic that will be maybe of interest to you. When we will get to that point, we will definitely get in touch with you and clarify what we want to do, and maybe you are interested in collaborating somehow on those things. Yeah. Yeah, and this is like our current network. So we have the IEEE Planet Positive, the WFEO, which is the World Federation of Engineering Organization, where all these global organizations are there, like the ISO, the UNESCO, and so on. The Net Positive Advisory Panel, the Flourishing Business Model community. We also understand we see that business models are very important aspects in sustainability. Common Earth, they do education. And then we have the Cradle to Cradle NGO. These are like very interesting from their design perspective that where from Professor Braungart, who also assumed that the designs with Cradle to Cradle NGO have net positive effects. I still didn't see it in numbers, but I don't know. Some also mentioned that there was in the building industry, but I still didn't see it in number, to be honest. But yeah, I don't know. And then there's like the cooperative business models, which is also like new business models and so on that are emerging now with the sustainability, and then the design theory society. Yeah, that's it. We meet actually like we have 2 meetings, Mondays and Wednesday bi-weekly, where we do these things. And yeah.
That's super, super interesting.
Yes, so maybe I can also like show you the GitHub repository where we will probably be publishing. So we're just like building a system model of this photovoltaic system. And so the idea is to make the project open source so that we have people from anyone can contribute and so on. And yeah, so here this is like the projects with like description, and then here we have like this SolarX is this like this the photovoltaic system company in the current state with the system model. We want to do the LCA analysis, and then to have like a baseline. Then from there we develop like the sustainable solution and show what changes and how sustainability becomes and so on.
That's super interesting. And how do you manage to fund that work? Is that
It's voluntary, so everything is voluntarily.
yeah.
Yeah, luckily we got AI that's getting more and more productive, so we get lots of help from AI. And no, otherwise, like it's mostly like volunteering people who get together, get a topic, work on it, make a publication, and then we make it open source. So that's kind of the approach. I think for the future, we will definitely also be looking into fundings and so on to try to get like more proper work, more capacity to work on these topics. Yeah.
Yeah, I think it's super impressive, and I'm super curious to join the conference in Stockholm. I really
Cool.
try to work.
Yeah, good.
I will be there.
Not
Yeah.
Stockholm. It will be Linköping. Linköping.
Linköping,
It's
yeah.
another
Did I say Stockholm? Sorry, Linköping.
No, yeah, Linköping. And yeah, welcome. And maybe it can give good, even better argument for us to say we will have a workshop, and if you want to come and maybe participate to discussions, so why not present also a Reboundless, have a working session, can be possible.
Yeah. That would be really nice. Yeah, let's definitely keep in contact in relation to that. It would be nice to meet you in person as well.
Yeah, I will definitely be there also, so this will be a great opportunity.
Yeah.
Cool.
And maybe we have a third co-chair with Alan Harding from UK, and I think he told me he should be there also too. Yeah, maybe I hope some people will be there. Really.
Cool, but thanks again for the invitation.
Thank you for your time.
Really nice.
That was very interesting, and yeah, I think we will definitely. I mean, as you mentioned, so it's a really design topic that we need to address at the beginning. So we will have very soon a deep dive into that, and yeah, we will get back to you when we get started. Maybe you get some point that you find interesting, then we see how we can follow up from there.
Definitely.
Good.
That sounds really good.
Yeah, thank you very much, and thank you also to Kai for organizing this, and everyone for joining and your discussion and your questions and taking from your time. Thank you. Ciao.
Thank you. Bye-bye.
Bye.